This class is an effort to familiarize the methods of studying numerical data and carrying out quantitative analysis, especially meant for people who are not very much familiar with such statistical approaches and tools. Usually, students are a little reluctant to use statistical approaches, statistical methods, and statistical ways of analysis because they fear a little about their ability to understand such things and use such tools for analysis. Statistical analysis of phenomena occurring around us will help us to approach the world with a very different perspective, in which you are not at all subjective. Usually, in conventional approaches of understanding and analyzing world phenomena, we are very much subjective. Our personal interests, personal bias, etc. will be influencing our inferences to a very high extent. This makes the results or the outcomes of your investigations biased. To avoid that, the methods in which only objective approaches are being used have been developed, and such methods are called numerical methods or quantitative methods. In quantitative methods of understanding and analyzing data, we usually approach or study or try to understand things based on the magnitude of the data, magnitude of the property which is being analyzed. On the other hand, in subjective analysis, we use qualitative data, qualitative information, and this qualitative information will be usually leading you to unscientific conclusions. For example, if you are saying whether a bottle of water is cool or hot, it depends upon your previous experiences. Or if you have first touched a cooler object and then you have touched a glass of cold water, you will feel that the glass of water is warm. On the other hand, if you have first touched a warmer surface, a hotter surface, and then you are touching a glass of warm water, you will say it is cool. It is cold. So the difference depends upon your previous experiences, your previous ideas and interests. And such an approach will result in conclusions that are different from person to person, from time to time, from experiment to experiment. To avoid that, the scientific world has developed numerical methods or quantitative methods, quantitative approaches to record and analyze data. And that is the merit of quantitative approaches, quantitative studies and quantitative research. And very often, students, especially students belonging to disciplines like biological sciences, social sciences, language and literature, etc., are not very much familiar with such numerical or quantitative approaches. And as a result, they become reluctant to study it, and the topics become difficult to them. And very often they usually try to skip from studying such things. So a basic understanding of the phenomena based on a numerical approach needs a little of training, and the first step in such a training is learning to approach anything and everything based on numerical data, measurement of data using standard tools of analysis, and recording data based on that. And strictly speaking, data means numerical information that are collected using standard tools of measurement. And anybody who repeats the experiment, the measurement, should get the same measurements again. Everywhere, every time, when you carry out the same experiment, the result should be the same. Statistical data are usually collected from the universe, from the units of your study directly. And such a type of data collection or such a type of data that are obtained directly from the objects of study, from the units of study, are called primary data. And primary data are the best and the most available informations that could be used for further statistical studies or analysis. But sometimes, due to several problems, you may not be able to collect the data directly. Under such circumstances, you will have to depend on other sources, which are called secondary sources of data. And secondary sources of data are sources that are already recorded and stored in different forms. Maybe it is a group of data stored in the census records of a country, or maybe data recorded as a part of statistical investigations carried out by the agricultural department, or like that. So, basically, there are two types of data: primary data and secondary data. So, primary data are data that are collected directly from the units of data collection. And secondary data are those collected from other sources. So when you are using secondary data, always you will be getting the data in an organized form. Organized form means you get data from tables that have already been prepared for one purpose or the other. But when you are collecting primary data, you have to use certain methods, or you have to stick to certain protocols and formalities. So the first step is the first step of collecting primary data is deciding the scope of your study and deciding upon the nature of your study population. So, in the beginning, you have to get familiar with certain terms like the study population, which is also part of the universe, a study unit, a sample, etc. So the first thing is a population, a study population. A study population in statistical terms means a group of individuals or a group of units from which you are going to collect data. For example, if you are going to collect or if you are going to study the problems, the health problems of people who were affected by corona after their recovery, if you are going to study their situation after their recovery, the study population is the people who recovered from the corona or the COVID-19 disease belonging to a particular area, maybe a particular district or a particular state, like that. So that is your study population. The study population may include thousands of individuals. And each individual, each person who has recovered from the disease is a unit of your study population. So the population is made of several units of study. So, as I mentioned earlier, there are several individuals in the population, in the study population, thousands of individuals in the study population. And usually, it will not be possible to study or to collect information from each and every individual. So for the purpose, you are very often forced to limit the number of individuals from whom data are to be collected. And for that purpose, you use a technique which is known as sampling. So there are two methods, obviously. The first method is using all the units of the population for data collection, and it is called a complete enumeration method or the census method. Complete enumeration method or the census method. In this method, you are collecting information from all the individuals, and if possible, it is a very good method because you are visiting and getting information from all the individuals of your study population. And the census that is being carried out in different countries every 10 years or like that is the best example for such a complete enumeration survey or census. So the next method is sampling. And in sampling, to study 10,000 individuals or to study a population consisting of 10,000 individuals, you collect data from a lesser number of individuals. A lesser number means it may be from a population of 10,000 individuals, it may be 1,000 or it may be 100, like that. And it depends upon the scope of your study, availability of resources and time, and based on such criteria, you will be fixing the sample size. And it is usually recommended that the sample should not be too small or it should not be too large also. So there should be a convenient size for the sample, and from the sample you collect data. So a sample comes in between the population and the unit, or a sample is an assembly of lesser number of units. So if it is 10,000, if the size of the population is 10,000, and if the size of the sample is 100, you can say that one individual in the sample represents 100 individuals of the population. So there is a proportion between the size of the population and size of the sample. That is the ratio between the two, and it is usually called K, and here K is 10,000 by 100, which is equal to 100. So if you are using 1,000 units, or if you are selecting 1,000 units in the sample, for the sample, the value of K is 10. So it depends upon the scope of your study and the resources available, time available, etc. And when you are conducting such a survey, for example, a study of a population based on samples, it is called sampling or sample survey. And sampling or sample survey should also have a scientific base. And here samples are selected based on certain principles which are known as the principles of probability. In other words, sampling is carried out based on the theory of probability. And probability theory, as you know, is a unique theory that touches every walk of life. and in one sense, which makes this world livable. Probability theory provides you the expectation that all bad things will not be with you always. Things will change for a better tomorrow. And for every night there is a day, for every depth there is a peak, and so on. So based on the principles of probability, the technique of sampling has been developed and designed. And usually, we will say that the process of sampling has been designed based on two principles derived from the theory of probability. And the first principle is known as the principle of statistical regularity, and the second principle is known as the principle of inertia of large numbers. Principle of statistical regularity and principle of inertia of large numbers. Principle of statistical regularity says that there is an order in everything. In the universe, occurrence of natural events take place with regularity in the occurrence of events of different types. For example, if you continue tossing a coin for a long time, there is no chance that all the outcomes are head or all the outcomes are tail. Surely there will be a group of heads and a group of tails. And interestingly, by and large, you will also be able to see that there is a proportion between heads and tails, and that proportion is almost 1:1. And this concept, this information that is provided by any and every natural event is known as the principle of statistical regularity. And the next principle is the principle of inertia of large numbers. To explain this concept, again we can come to tossing of a coin. For example, if you are tossing a coin 10 times, for example, you may get 3 heads and 7 tails. You may get 4 heads and 6 tails, or you may get 6 or 7 tails and 3 or 4 heads. But if you are repeating the process of tossing for a large number of times, for example, say 100 times, 1,000 times, this difference between the number of heads and number of tails, that is 7 plus 3, 6 plus 4, like that, this proportion will be getting reduced. and the ratio between the occurrence of heads and tails will be tending to be or they will tend to become rather 1:1, or the values will be 475 plus 525, or 480 plus 520, or 490 plus 510, or 499 plus 501, like that, which will be more similar to your expectation of equal occurrence of head and tail. So these are the two concepts, the concept of inertia of large numbers and the concept of statistical regularity are the two concepts on which the theory or the process of sampling has been done. So sampling techniques are scientifically framed based on the principles of probability, and these are usually otherwise called random sampling methods or probability sampling methods. But sometimes, due to certain reasons, due to the nature, certain particular hidden periodicities of your population, or certain trends that are shown by your population which are not desirable, also due to such problems, sometimes you will be forced to use or to make your own decisions on sampling methods. So, under such circumstances, you use methods that are not having a statistical or that are not having a probability base. And such techniques are called non-random sampling methods, and these are rarely used under some situations where you cannot apply random sampling methods. So now we are going to explain random sampling methods. Random sampling methods, as you know, are based on the principles of probability, and the methods thus are designed in such a way that your ideas or your likes and dislikes will not be affecting the outcome of your sampling technique. So, you are using probability as your tool, you are designing the methods, and that's the most important advantage of a sampling technique, a random sampling technique. And in random sampling technique, there are different types. And the first type is simple random sampling. In simple random sampling, for example, if you have 10,000 individuals in your population, you have to give equal chance of getting represented to each and every unit in your population. And usually, the simplest method that can be used in simple random sampling is lottery method. In lottery method, you give serial numbers 1 to 10,000 to all the units of data collection of your population, and you will be writing down the serial numbers in uniform pieces of paper, making them or folding them as lots, and all the lots will be put in a box, mixed uniformly, and you will be asking a third person, a person who is not connected with your experimental process, will be asked to take out the required number of lots from the bulk of lots available in your box. And here also, the best method is taking out the first lot, noting down the number, depositing it again in the box, mixing again, taking out the second lot, reading it or taking the information, folding it again, putting it back, and repeating the process, so that always at all the points of your sampling process, there are 10,000 units in your population, and from 10,000 you are selecting one, and this will be repeating. For example, if you have 100 units in your sample, or if you have to collect 100 units for your sample from the population of 10,000 individuals, you will be repeating it 100 times, and these 100 units are listed out, and this forms your population. But here you see there are 10,000 individuals, and if you are going to list all the individuals and make 10,000 lots, it is the best. And sometimes you may feel that even such a process will not be sufficient for representing all the units of your population. For example, you think that your population is spread all over Kerala. And if you are collecting 100 units from your population size of 10,000, there is a chance that more number of units are from a particular geographical area, and there are no units from some other geographical areas. For example, from some districts. To avoid this problem, you are using different types of restricted random sampling methods. And the first one of this type is known as stratified sampling. For example, in the study you are carrying out, in which there are 10,000 individuals scattered in 14 districts of Kerala, for example, you will be fixing strata. For example, you will be studying, or for example, you will be dividing your study area into 10 strata or 14 strata, 14 districts, like that. And from each district, if you are collecting a particular number of, or if you are selecting a particular number of units by lottery method, you are sure that all the districts are represented in your sample. So that is stratified sampling. You are dividing your population into different strata, and from each you are collecting a particular number of units to make your sample. Another type of sampling is systematic sampling. In systematic sampling, you will be serially numbering all the individuals, and if your population size is 10,000 and your sample size is 100, you will be selecting, in general you can say you will be selecting every 100 item. For example, you will be selecting the first item, the 101th item, 201th item, 301th item, 401th item, like that you will be reaching 10,000. So, every 100 item, for example, will be getting a representation in your sample. So, that is the next technique, which is known as systematic sampling. And another technique of simple random sampling, another technique of random sampling is multi-stage sampling. It is a type of restricted random sampling, and it is very similar to stratified sampling. And the difference is that there is sampling at 2 stages or more than 1 stages. You will be dividing your population into a number of strata, and from each you will be having a sufficient number of individuals or units of data collection, and you will not be collecting data from all the strata. So there will be different steps of sampling. In the first step you will be randomizing, or you will be selecting at random a few strata, and from the selected few strata you will be again selecting the appropriate number of units. So there is selection, randomization and selection at the first step, and randomization and selection at the second, randomization selection at the level of strata and at the level of units. So these are the different techniques of the different techniques of random sampling, and sometimes you will be forced to use non-random sampling techniques. As I mentioned, non-random sampling is carried out for other reasons, and here it is not based on the principles of probability. It is done either for convenience, or it is done based on the judgment of the individual who is carrying out the study. And there are different types of non-random sampling techniques also, and the first one is judgment sampling. In the judgment sampling, you will be exercising your discretion whether a particular unit is to be included in your population, or whether a particular unit is to be included in your sample. So you will be judging the unit before inclusion in your population and before selection to include in the sample. Maybe you are not having a complete list of the units, or the units of data collection are rather having no such clear-cut properties that make them a unique group. Sometimes your judgment on the quality or on the properties of the unit will be important. So you will go for judgment sample. Another type of non-random sampling is known as quota sampling. And in quota sampling, also you will be using certain parameters which are already known to you to decide the number of units to be included in the sample from each stratum, to decide the number of individuals to be included from a particular group, etc. Your experience and your decision on the quota of the number of individuals to be included in the sample from each group or each strata will be important. So there is a decision made by the person who is dealing with the experiment. So in total, as you know, if you are going for a statistical study, studying world phenomena using quantitative tools of analysis, the first step is collection of data, and for collecting data, either you will collect data directly from the individuals, and then it is called primary data, or you will use other sources of information available, and data collected from such sources are known as secondary data. And if you are using primary data for your study, you collect it either using a complete enumeration survey or a census method, or you will be using a sampling technique. And when you are going for sampling, you use either a random sampling technique or a probability sampling technique, or sometimes you use a non-random sampling technique. And scientifically based method of sampling is random sampling, and non-random sampling is carried out for certain other reasons. Thank you.